Hi everybody. Today we're doing something cool. While I was prepping, while we were out, while I was sort of doing the permanent rigging, the final rigging on the ailerons, I thought, let me just take off this wingtip and see what this looks like underneath. And holy crap, I'd forgotten to make an actual mount for the GMU 22 magnetometer. So that's what we're doing today. So we have the previously made rack that we've got for the magnetometer, which is cool. The only thing we haven't done is found a way to secure it to the side of the wing here. So what we're doing is we're taking a couple of pieces of 3/4 inch angle aluminum, and we're making a top and bottom guide rail for it. And we are going to be mounting that to, we're going to be mounting the magnetometer mount to that guide rail. So we're actually putting two locations in. So the idea is that, magnetometer sits out on the wing, that's your flex gate, it tells you what your orientation is in Earth's, magnetic field. And you want it to be as far away from anything magnetic as humanly possible. So what we've done here is the guide rails that we're putting on are going to be very long, and they're going to be very long for two reasons. One, we want to have it be very strong. So it's going to be attached to that outer flange in 3 different places. Why is that important? Well, if you look at the guidelines for installing the GMU 22 in a certified plane, part of it is that, once it's mounted, you should be able to put 20 pounds of pressure onto the mount and have it not detach from wherever it is. Right? And if you just simply attach it very plainly to that outer flange and you start putting close to 20 pounds of side pressure on that thing, you start to bend that last wing root rib. And we don't want to fudge that rib up. So we're putting a couple of really long pieces. Also, the second reason that we're putting it on is because we're doing it and actually making 2 mounting spots for it. So there's going to be a back mounting spot and a forward mounting spot. The idea behind that is we're going to put it in the forward mounting spot, and then we're going to do a magnetic interference check, right? It takes a couple of minutes where you turn on and off all of your electronics. You move the aileron around because there's a steel bar in it, and metal that moves through air has a tendency to create a magnetic field, etc. And if that location is no good because it's too close to, say, the big pulsing lights in the front, we can move it to the back location and check it there. Now, the other reason I'm putting 2 locations is because, much like having a secondary ADAHRS backup unit on the back of your G3X modules displays, you can also have a secondary ADAHRS. So I thought, I'm going to go ahead and leave room in case I want to have a secondary, you can have a secondary magnetometer. So I thought I'm going to leave room in case I want to install a secondary magnetometer. I already have an extra pair of wires going out to the wing, so using that to supply the power to the secondary one wouldn't be too difficult. We've got the CAN bus already out there, so patching that wouldn't be difficult either. Why would you need a backup? Who knows? But the ability for it to be there is always nice, I think. And then it just mounts on with AN hardware like anything else. And again, so when you work on this, make sure that you are using non-magnetic tools. You use a magnetic tool, you can induce a magnetic field into a metal part. And unless you degauss that, which I don't think any of us own a degausser anywhere around, you can impart a magnetic interference. So that's why I have a brass Phillips head screwdriver, just for that. All right, good news, end of the week. Bad news, this is the last video until I get back, so I hope you are doing well. I'm still on vacation. I will see you guys next week, so thank you for joining me. See you soon.